computer. It says, write a recursive function that takes in a number and returns the associated number in the Fibonacci sequence. The sequence begins with 0 and 1, and then the next number at any point in the Fibonacci sequence is formed by adding the previous two numbers together. Thus, the full sequence is 0, 1, 1, 2, 3, 5, 8. So 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 8 is 13, and so on, so on. So on and so forth. Excuse me. So with that, we have to write a recursive function. So 3, so what does it say? The sequence begins with 0, takes in a number and returns the associated number in the Fibonacci sequence. So 0, 1, so 1, 3, 1, 2, 3 is 1, 7, 1, 2, 3, 4, 5, 6, 7. Okay. Let's run this. So if we 0 or 1, so the first thing we can do is determine our base case. What is our base case?
If sequence is less than or equal to 2, it's the sequence number.
So if it's less than or equal to 2, but what if we pass in 0? Then it would be 0, right?
Right.
So if it was less than or equal to 2, so our base case, I think we might have two base cases. So like if sequence equals 1, so for 1, we should probably return 0, right? Else, if sequence equals 2, we can return 1. So those are just in case someone puts in 0, or I'm sorry, 1 or 2 in there. Else, we have to return so let's check this out. So if, what is it, 7, we have to, what do we want to do? So if 7 equals 8, how can we determine that? Does anybody know? Let's just.
It's the 2 before the 5 and the 3.
Yep. So we can return the Fibonacci sequence, the initial value, which is like 7. So 0, 1, 2, 3, 4, 5, 6, 7. Sequence minus 1 plus Fibonacci sequence minus 2. And I just want to run this real quick. Console log sequence and see what happens. So if I run Fibonacci sequence here, run that, I get 3, 2, 1, 1. So the initial time, 3 is entered into here. 3 minus 1 equals 2, plus 3 minus 2 equals 1. So 1 is here, and then I'm passing in 2 there. So it comes into here, It says else if sequence equals 2, which I'm passing in this first one. So 3 minus 1 is 2. So it comes in here, returns 1 right here. So this one ends it right there. And then let's try 7. Ooh. 8. Oh man, see that's really long because it runs through it a bunch of times. So there's 8. If I do 16, you're going to see it execute a lot of times. Execute. So look how many times it's executed the Fibonacci sequence. That function 16, 15, and just keeps on going. So if I run that, there we go. So that's the recursive case.